So 6.3 is trig functions of any angle. We spent yesterday talking about specifically right triangles. We've also, before spring break, talked about special triangles and then just talked about SOHCAHTOA in general. So 6.3 is about trig functions of any angle. You have, on a coordinate plane, when you write out an angle, you have an initial side and you have a terminal side that it's going to, which is you start here, terminal means the end. We want to remember that a positive rotation is counterclockwise, a negative rotation is clockwise. So if you're looking at trig functions at any angle, you'll notice a lot of the time they'll take this little angle that they're going to draw and they draw it in the direction that they're moving. So since this is moving counterclockwise, it's a positive rotation. Mathematically, what we end up doing with these is we do coterminal angles, and they're the same. They're the same as the current angle that you have, but they're after a rotation of 360 degrees or 2 pi. I know we did these in class before, so I just wanted to reiterate that when we do these problems, you have to find two positive and two negative coterminal angles. In this case, we're going to look at 100 degrees. So when it says two, it literally means you're going to find two of each, not just one. So you add 360 once, you get 460. You add 360 again, you get 820. That is two positive. And then you find two negative. So 100 minus 360 gives you negative 260. I forgot my degree symbol. And then minus 360 gives you negative 620. So you want to make sure you have two of each. And then if for any reason you're given a radian, you can either work with radians or you're more than welcome to convert it to degrees. So you don't always, if it's given in radians, you don't have to stick with radians. You can convert it. Are we okay with this?
Yeah.
Okay. All right, we also talked about complementary supplementary angles, and you've talked about these before. Complementary being when they sum to be 90 degrees, supplementary when they sum to be 180. Sometimes you'll be given a problem that you can only find one of them if they ask you to find both, because it's larger than 90 degrees, so you can only find its supplement. But with that being said, we did one that you can find both. So you have find the complementary angle and supplementary angle of 71 degrees. That's really simple. You just take 90 degrees and minus 71, get 19. You do 180 minus 71 to get 109. So pretty straightforward, nothing too terribly crazy. This brings us to how trig functions of any angles work. All right, so if you're writing this out, let me move this back up real quick so you can have some time. We talked about SOHCAHTOA, and I think I've written this out this way for you all before as well. So I want to reiterate, and I'll show it in the next example actually. Sine is y, so sine goes over a radius on the unit circle. Cosine is x over the radius. Tangent is y over the x value. Cosecant, you just flip sine, so it's the radius over y. Secant's the radius over x. Cotangent's the x over y. I'm going to flip this back over just for a second so I can kind of talk about something on the previous page. When they talk about x and y, this is where your angle ends, right? So they look at a triangle here, and like this would be your y-axis, this would be your x. So it is related strictly back to right triangle trig from yesterday. And I'll give a second if you guys need to write that down. Or if I need to go back to the last page because I was kind of going fast, let me know. All these notes will be posted on Classroom as well as they normally are. And this is, like I said, I'm pretty sure we've talked about this section before, but I didn't see a homework set for it, and I didn't see it on my lesson plan, so I just wanted to make sure, even if we had going back over it, it's good for review, just to see the different notation from 6.1 for the trig functions. All right, so moving on. All right. Now you have a coordinate plane, and if you remember, I used to talk about Well, here, x and y are positive. Here, x is negative, y is positive. Here, they're both negative. Here, x is positive, y is negative. Well, we can use that same idea, but apply it to trig functions. So what I've done is in green is the positive outcomes, in red is the negative outcomes. So in quadrant 1, everything's positive, none of them are negative. In quadrant 2, sine is positive, cosine, tangent are negative. In quadrant 3, tangent's positive, sine and cosine are negative. In quadrant 4, cosine's positive, sine and tangent are negative. If you're wondering, hey, how the heck did he figure that out? Well, sine's y is positive, x is negative. Since this is y over x, tangent would have to be negative. Here, they're both negative, so tangent has to be positive. It's literally just following the x and y coordinates. So nothing terribly new there or terribly interesting. So the reason that's important is when you're working with a triangle that says find all 6 trig functions, and they have it written on a coordinate plane, if it's in quadrant 3, you know sine and cosine should be negative and tangent should be positive automatically from the get-go. So if one of those things doesn't line up, you know you goofed. Here, our x value is -4. Our y value is -3. We always make the angle with the origin and the x-axis. So if you had a different triangle, I'm going to write it in green. If you had a different triangle over here, all right, you always write with that in mind. Like theta is always between the origin and the x-axis, no matter where your triangle is. Same thing if you drew it here, and same thing in quadrant 2. I'm not going to go all the way over there right now because we're working on this problem. If you want to know the hypotenuse, Pythagorean theorem, a squared plus b squared equals c squared. You work that out, you get 5. Okay? Then it's just plugging everything in. So sine theta, well, that's y over the radius, or opposite over hypotenuse, however you want to remember it. -3/5. Cosine, x over radius, so -4/5. Tangent, 3/4. And they're both negative, so it goes positive. And then for the other ones, you just flip them over. All right. That is all there is to 6.3. I wanted to offer a bit of a review because I thought it could be good. Like, this is small stuff that's easy to forget about, especially when we had a week off with spring break. So hopefully that's a little bit of a good refresher for you all. Is there any questions I can answer?
How are you doing today?